Hello. Welcome to my talk on upgrading to Angular without ngUpgrade. And thank you for joining me at the end of the day. I know it's been a very long day with lots of great talks. So here we're going to talk about upgrading without ngUpgrade. When I think about this topic, and as I'm trying to figure out these slides, like as I was creating them, I started thinking about it in a different frame. Instead of upgrading without ngUpgrade, I thought of it as never upgrade again. There we go. So never upgrade again. How can we upgrade our apps right now and then never have to worry about it for other pages? So what I'm going to talk about, first I'm going to talk about custom elements. We're going to go over an overview of what those are and how they work. Then I'm going to talk about upgrade, the reason we're all here today. And finally, I'm going to talk about how we apply this to other frameworks. And you'll see why that's important for me specifically in a minute. So they saw me, but that's me. I'm pointing over at my face. My name is Erin Coughlan. I've been a software engineer at Google for the last 4 years. And during this time, I've worked on Google Analytics and the Google Marketing Platform, which was formerly known as Google Analytics 360 Suite. I also am the owner of a cross-product component library. This giant screen over there is the Google Marketing Platform homepage. The Google Marketing Platform combines our advertising products with our measurement products, so things like display and video 360 with Google Analytics, to help advertisers, marketers, better understand their network traffic, make better decisions about their websites, and improve their business. My favorite part about working on this is not the ads part. My favorite part is making it easy for all of these different companies to achieve their goals, their business objectives. And that's really why I'm here today, too. I want to make everything that you do as easy as possible with as minimal effort. The second main project I work on is the shared component library. The main part of this is a shared header. So you'll see this header that's in Google Marketing Platform Home, Google Analytics, Attribution, etc. This header helps customers navigate from one product to another one, helps them better search, find their entities. And what's really interesting about this, and why this talk came to be, is that it's not all Angular. It's not even all AngularJS. We have frameworks upon frameworks upon frameworks. So AngularJS, Angular, Angular Dart, Polymer, Google Web Toolkit, or GWT, if you still remember that, and even Clojure Component Library. So the Clojure compiler you might have heard of, they also have components. All of these are together, and we have to interface with all of these different frameworks. Currently, we're doing that with AngularJS, but we want to use the new cool stuff. We want to use Angular, we want to use Angular Material, those component libraries, everything. So as I was coming up with this talk, I really started looking at all these frameworks and how if you switched from one to the other, you basically rewrite the world. And it just drives me crazy. Like, why do we have to keep rewriting everything whenever we change? If you get into a new company, a new organization, rewrite all your application. Great. So that's not what I want to do here. Instead, I want to say, what if it didn't matter? So first, I'm going to talk about custom elements. And this is going to be our main key here on how we get all of these to work together and how we solve this ngUpgrade issue. So custom elements are part of the web component spec. And what this says is there's a set of web platform APIs that allow you to create new, reusable, encapsulated HTML tags. You can use this in your website, and it will work across modern browsers and with any JavaScript library or framework with HTML. So in the end, every single one of those frameworks I said executes in the browser. In the end, they're all JavaScript. They're all HTML tags. How can we use that to our advantage? Custom elements is a small part of this spec. It looks something like this. We have our class, JavaScript class for Hello World. It extends an HTML element. And that's it. We go ahead and we define this with the custom elements. So we define our selector, hello-world, and we pass in this class. What's cool about these custom elements is they have a very defined set of APIs. So they have something called a connected callback and disconnected callback. This is what is called when you initialize this component and destroy it. So from the Angular world on init, on destroy, that might be something you're familiar with. They also have a list of attributes. In this case, our hello world component is looking at name, and we know whenever this changes. So whenever an attribute changes, we can go through and update our component. We have properties. So instead of just attributes, which are strings, we can have more advanced data within properties. So you can think of perhaps a name property has a first name, last name, a middle name, and we can just set and get that with that data without having to then put it in JSON, serialize it, deserialize it. I've done it, terrible idea. Finally, we have this dispatch event. So we can create custom events. We can create a custom language for how outputs work, and then we can dispatch it. Anyone listening to this can then hear or respond to it, update the screen accordingly. And what's great for us, we're enterprise application. We support a lot of different browsers. And custom elements work in Chrome, Firefox, Opera, Safari. And there's polyfills available in IE all the way back to IE 9. So this means we can use it. Like, this is amazing for us. Angular Elements is something specific to Angular. So they took the Angular component you might be used to writing, and they combined it with the custom elements. So they found a way to take the Angular component and write it in this framework-agnostic way, this way that every browser understands. Let's see what that looks like. So here I create an Angular component. I specify a tag, hello-world, same as before. And you can imagine here I have a template URL, style URLs, all the stuff you're normally familiar with components. We have an input and an output. So the input is a name, the output is this change event. So whenever I update the name, I output a change event. When I go through and bootstrap my application, usually in some kind of main file, I put all of these modules together, I include all of these components I built, and then after I get the injector, in this giant yellow box, and expand out, I can create these custom elements. So create custom element comes from the Angular-elements module. This you pass in the component that you wanted to have access to, the shared injector state, and it goes through and creates that custom element I showed you a little bit earlier. We specify here another selector. For best practices for us, what I did was I actually used -CE for -custom element, just so it has a different name than the Angular component. We have a way to differentiate the two. Then we just define it with custom elements, and we have this new Angular component, or custom element based off of Angular. And it looks something like this. So hello-world-CE, pass in the inputs I have, and that's about it. I can interact with these attributes, I can update the properties, and I have all of the same fields that I'm used to. Now for why you're actually here. So how do we upgrade? Just spent about the last 10 minutes or so talking about custom elements. I'm telling you about these cool Angular elements and how awesome they are, but how does this help you upgrade? How does this help you get from AngularJS to Angular? So this is your Angular application, and that looks like me and my team back when we started this. We knew about all the new stuff, we knew about Angular, but we had 200,000 lines of code. It's not something we can just like toss aside and then rewrite. Managers, product managers, they don't really want us to stop writing features for years, possibly, while we redo this. And so we needed to come up with a way to incrementally migrate from AngularJS to Angular. A rule we use on our team is whenever you have to find a bug in a component or have a new feature, write it in Angular, then use it back in our existing AngularJS applications. So we can go from this sad kitten to a very, very happy kitty. So everything here is Angular, and if you follow some of the instructions here, you'll be able to migrate your own applications from AngularJS to Angular. But how do we actually do this? How do we form this incremental migration? So what we do is what is known as a bottom-up approach. So we start with our whole tree. Everything here is AngularJS. Every single component, every page, the router. In our case, we use UI router. You might be familiar with that. And we upgrade just one little component. One little box in the corner goes from AngularJS to Angular. And then we do a few more components. Maybe we finish an entire page. And then we do another page. And eventually our entire application is Angular. So we're done. Yeah? Easy? But not so much. So we are this component library. I said I wanted to make this work in every single framework. How can I get this to work in AngularJS? How do I get it to work in Polymer? Even Angular Dart, something that doesn't compile to JavaScript. In our case, we might not have control over this execution environment. Every team gets to choose what framework they wanted to use. And every framework has different advantages. Polymer, for instance, works with those custom elements. It's really, really fast. Angular Dart is a lot more familiar to people coming from Java. It's less of a scary language in that case. And so everyone controls this environment, but we want to be the one little red box of Angular. That's what our team wants to work on. So Angular elements. So if you followed the first part, we know that the answer here is probably Angular elements. So let's look at a traditional way. So with ngUpgrade, you rewrite something in Angular, and then you can just use it in AngularJS. They share this common injector state, and they can share the injectors between AngularJS, Angular, pass data between the services, use components in different places with upgrade and downgrade. With this approach, we introduce this box in the middle. We introduce this custom element in the middle as our common infrastructure, the common interface that the browser understands. What's great for us is then we can use Polymer, React, whatever framework we want, because everything actually understands the custom element code. It wasn't so easy, though. We thought of this great idea probably 6 months ago at this point, that we're just going to use it. It's going to just stick it in AngularJS. Everything's going to work. It's magic. We don't have to do any work. But we quickly learned that was not as easy as we wanted it to be. So there's attributes versus properties. I mentioned earlier in the talk that we wanted to use properties. We wanted to have complex data structures and being able to set and get these properties. AngularJS, up until very recently in AngularJS 1.7, only worked with attributes. So we have to translate these attributes to these properties. And even with the recent pull request, the properties have a different name. So it's ng-prop-whatever, instead of just defining the field, for instance, name. Second, we have those custom events. These events are happening outside of AngularJS. We don't know that they've occurred. We don't respond to them. No change detection occurs, but we have to listen to it. How do we get listening to these custom events? And finally, change detection. How do I run change detection in AngularJS such that the whole application updates whenever one of my input changes, whenever one of my events are fired? And introducing, drum roll please, create ng1 wrapper. So I said I wanted to make this easy for you. I created this wrapper, create ng1 wrapper, and put it up on GitHub. So this is something you can use today to basically bridge the gap between custom elements and AngularJS. The create ng1 wrapper is the layer of communication between custom elements and AngularJS. It creates and destroys the component, it configures the inputs, it transforms events, those custom events, into the traditional AngularJS outputs, and it triggers the change detection. So we've jumped between the custom element directly to AngularJS. Let's again see how this looks. So this is the code we saw a little while ago, where we've gone through, created a custom element, and then we've defined this new selector. The next part is we just call create ng1 wrapper. You import it, you pass in the same selector, the same component, the same injector. So you get the exact same state, and you have access to the inputs and outputs. The final step of this is just registering it with an ng1 module. You now have an AngularJS component, which underneath is actually Angular component, but no one really knows that. There's no reason for anyone to see that. Again, here, we use a different selector name. So dash wrapper is something that we chose. You can think of something like dash ng1, for instance, also would work. And this is what it looks like. So this is our AngularJS template. If you remember back, we have the ng controller with controller as syntax. And then we use our wrapper. We pass in the input, which is the name, and we pass in the output, which is this update function. And in the AngularJS controller, just for completeness here, we have our name, Devoxx, and we have the update function, which is going to alert this. So now it's time for a demo. When I said I was doing cats, and I said I had this demo here, this is our now famous cat, Simba, from Yonk's. It's his cat. So let's see what this looks like in a demo. Okay. So the code here is, the code up on the screen right now is an Angular component. It uses the material menu. So I said we wanted to use those new material components. And it just has a button that emits a new meow event. And it passes in whatever our current cat is. So the component has an input and an output. Exactly the same as that demo I was showing you with Hello World. But I've switched it to cats because they're cooler. So our main file. This is the same code up here that I showed you in the demo. So we go through, we create, is this going to work? There we go. We create our custom element with our component. We pass in our selector, which is this new cat selector with -ce. We create our ng1 wrapper, and then we register it with an AngularJS module. And this is just the Angular application. So it has a kitten, and it passes in the current cat and the meow. So here's it working. This is an Angular application, 100% Angular. I'm not doing anything special here. But we have our dropdown, it says Simba. You can switch to Garfield. It updates to Garfield. Nothing here should surprise you. This is if I had a pure Angular application. The interesting part is this AngularJS dev server. So in our AngularJS dev server, we have our favorite cat, Simba. This is our input that we have in AngularJS. And we have our wrapper. This dropdown here is actually the Angular component I showed you in the other slide, or on the other server. When I click on it, I can switch to Grumpy Cat, and we have an alert. So we're actually responding to the outputs. This dev server likes alerts, so we're saying it's the most famous cat, that's the best one. And that's it working. That is AngularUpgrade without using ngUpgrade. To this AngularJS dev server, nothing here has touched Angular. It was given an AngularJS component. It used it in the module. It used its attributes like it always wanted to, and it has no idea. So our component library is now able to upgrade to Angular without actually changing any of the APIs for anyone else. So let me go back to the presentation. All right. So what did we accomplish? Like I just said, we now have our Angular box inside this AngularJS application. But that's not the all the way. So AngularUpgrade, Angular applications, it's more than just components. We have services. So how do you provide data to the component? Option 1, rewrite it. Why not? You have to rewrite everything for Angular anyways. So you have two services, they both make HTTP, it seems fine. So we have the AngularJS service. It uses, this is written in TypeScript, so it uses this angular.iPromise, which is just the AngularJS promise. We use $HTTP, and we get a bunch of kittens. We adopt a bunch of them. In Angular, we just switched to observables. So we rewrote it from this iPromise to observable. Angular has an HTTP client, which replaces our $HTTP. But basically, it's the same code. It's not too bad. Except you keep making changes. You fix some bugs, you get a reorg, you re-architecture it, design it, and what happens? It just diverges. So now you have these two services, and you fixed it in some places, but not the other. Like, I'm lazy. I'm going to make the features, I'm going to fix it in the real place, but I'll mess up the other one. So I'm going to suggest something different here. So instead of just writing it twice, we're going to introduce a framework-agnostic service. So this is similar to the custom element where we're creating a common interface regardless of our infrastructure, regardless of our framework. So our adapter here makes our HTTP request, and then it's wrapped in AngularJS and Angular. I'm going to show you what this looks like. So here's the framework-agnostic service. We just return an ES6 promise, we use window fetch, we get our kittens, return the JSON, and everything here works. If we have error handling, we would add it to this service, and we don't have to worry about touching anything else. Similarly, if we have additional functionality, like maybe you have to do data parsing, or you have to somehow do some transformations, it's in one place, not two, less errors. So in our Angular wrap service, we create this cat service, and then we want to return observables. We want the services to still look like the framework they're in. So in this case, I'm used to Angular, I'm used to observables. So we're going to return an observable. Any of my Angular components can then use the Angular service without caring what I did underneath. Similarly with AngularJS. In this case, I want that I promise. So I call the adopt the kittens, and then I call, in the then, I call root-scope.apply. So the tricky part here is that $HTTP and the HTTP client both did different logic to trigger change detection and help manage requests. By pulling that out and using this framework-agnostic one, we no longer have access to those additional services. So we're responsible for doing it on our own. My team found that it was very, very easy to forget the root-scope.apply here, and then your app just doesn't update. So we wrap this again in a manage request service, which we pass in, and it automatically runs the root-scope.apply. So you can think of it like we created our own $HTTP that just does a simple case. But what does this accomplish? So now we have our AngularJS components talking to AngularJS services using this framework-agnostic one. And we also have our Angular components talking to our Angular services, also using the same root code. So as we go through and migrate from AngularJS to Angular, you can have both of these pointing to the same code location, and you never have to do it again. So if you had another one in here, some other service, you create another wrapper, you pull it up at the top, and then it's still talking to the framework-agnostic one. It has the same behavior as you had before. So you no longer have to think about that. Providers are next. In our case, providers mostly become inputs. So you want to think of the custom elements and these Angular elements as black boxes. If you need a provider, if you need some kind of data, you either should fetch it with the services we showed you, or we should pass it in as an input. Let's see another example. So in this case, I want to inject an API key. Maybe I'm talking to one of the cloud services, and I need this special API key. And usually, if I wrote this all as Angular, I would just put it at the root, inject it through, put the constant at the root, inject it throughout, and not have to really think about it. But in our case, we can't guarantee that that root exists. We can't guarantee that someone else set it. We want to think of it as a black box for us. So only thing that changes is this API key becomes an input. You have another input to your component, you pass in the API key, and you can still make the request as it was before. Next is routing. You might have thought of this one. So if I'm writing this with these custom elements, how are they going to tell the Angular router or the UI router to update? So when you use ngUpgrade, a lot of times you have this dual router situation where they both control different pages. In our case, however, the whole page is a custom element and the routing is outside of our component. So here's the code before. You have something that you pass in the router and you just navigate to this home page. For instance, when I update some button or update a link, I just navigate to it, and whatever's there, the Angular router navigates to a new location. We change this to an output. So providers are inputs, route changes end up being outputs, other ways to change this global state. So whenever I want to update the route, I just emit this new type. So in this case, I admit home. And what's cool about this one is we don't care what router we're in. We don't care if you're using UI router. We don't care if you're using Angular router. We don't care if you wrote your own router. We just need you, or whatever the application the components are in, to respond to these events. So you have something listening to this update event, and it updates the route to home whenever this happens. And it can choose its own URLs. Maybe for our library, we have 2 different URLs. We have them in 2 different applications. With outputs, we don't have to worry about it anymore. Both applications can have their own route. And there you go. That's your new Angular application. So you're able to use custom elements to update components. You're able to use framework-agnostic services to make requests, fetch data, and inputs and outputs. And through all of this process, you're able to go from the bottom up and translate small chunks of your code to larger pieces of it. So the next part, and the final part of this, is how do we apply this to other frameworks? I mentioned a little bit that this is something that we want to work everywhere. So we have our custom element works in every browser. We have that Angular element, which goes from our Angular components to the custom element, and then we have the create ngOne wrapper that goes from the custom element to AngularJS. But what if you have more? How do you go through and figure out what the create ngOne wrapper does? How do you create your own Angular elements? So this is what we do. We have Angular, and then the thing in between the Angular elements is this ngElement strategy. That transforms us to the custom event, or custom element, and then we use our ngOne wrapper to go to the AngularJS component. The strategies are responsible for these layers of communication. So ngElement strategy is between Angular custom element, creates, destroys it, the component, configures the inputs, transforms Angular outputs to our custom events, and triggers change detection. So somehow Angular has to know that changes are happening. Create ngOne wrapper, basically the same idea. Between custom element and AngularJS, creates, destroys the component, configures the input, transforms our custom events into AngularJS outputs, and triggers change detection. So a lot of functionality wrapped in this little tiny code. Like if you actually go on GitHub and look at it, it's like 180 lines of code for both of these services. So inputs. How do we go from AngularJS, we update that attribute, and end up in Angular? How do we tell Angular components to update? First, we go through and we change our attribute. We update it to a new value. We want to transform this to a property. So we know custom elements, we know we have properties. So you have that middle part already defined. We set the property to this value, and then we actually set it on the custom element. So element.property equals value. We've jumped over to the other side. So we know our input here is in custom element is a property. We set this on our ngElement strategy, which then calls on changes. So we need Angular to be aware that this thing updated. We need it to go through, trigger change detection, and run any change functions you have. It sets the actual property all the way through, and then actually runs the detect changes, which updates the browser. So if we look at this together, we go from our attribute value to a property on our wrapper, to a property on the custom element, to an input to our element strategy, to Angular, where it is just an input. That runs change detection, runs on changes, and then updates the browser. So updates in AngularJS, going through all of these different layers, with the custom element being your common ground, like you already have all the properties defined on there, to Angular to update. Likewise, we can do this with outputs. So how do Angular events reach AngularJS? So in Angular, we have outputs. We are firing, or we just have an output, like at output. So we emit an event. We emit our meow event. The Angular element strategy is subscribed to all these events. And whenever one of these events happens, it creates a new custom event and then dispatches it. So we actually fire these custom events from our custom element. The element dispatch it goes into our create ng1 wrapper. Here we're just using browser standards. I'm fired an event, I'm adding an event listener, and whenever that happens, I go through and I fire the AngularJS event. And this is the output. So this .meow here is our AngularJS output. We pass in $event. So if you remember something like ngClick, you used to be able to pass in $event. And so we want to keep the API the same. If you're expecting the events to have access to the thing that's actually fired, we pass that through. Detail is a special word here. So detail is the actual thing that is being emitted. So if it is like a string, for instance, or like in our route change example, detail is that piece of information. So when we emit the detail, we're able to access that piece of data. And again, we have to run change detection. So we run this root scope.apply, we tell AngularJS to update while responding to this input, or sorry, it's responding to this output, and then the browser updates. So altogether again, we emit a meow event, we subscribe to that event. So the ng element is subscribed to it, we create a new custom event, we dispatch that event, we just listen to it, add event listener to this meow, and then we run our output function in AngularJS. It's a big, long, expanded thing. But really the thing here, and why should you care? Like, why is this special? We created these little wrappers, and somehow using this custom element as the middle, we have a browser standard for inputs, outputs, events, attributes, properties, and everything there is defined. And it works everywhere. So our custom element works in every single framework, and it works in every single browser. We want to be able to create we want to be able to go from our custom element back and forth to each of these frameworks. Because what we want in the end is actually this. In the end, we want to create something in Angular that will go everywhere else. We want it to be able to write it once and have it work everywhere else. And that's what we do with these strategies. That's what we do with all of these adapters. Same thing we did with the services. When we wrote that framework-agnostic one, it's just another adapter. And you can think about this a little further. So Angular has Angular elements. What about these other ones? You can think of any other framework over there, but how can it go from a framework component to something everyone understands? If we can go from all the red boxes to the gray box and back to the blue box, we stop arguing about what framework is the best, which one's better. Everyone can write what they want, and it can be used anywhere else. No more writing the component 10 different times because you need it in 10 different places. It helps us share more. It helps us move faster, write better code, use our resources where we need to, and just generate a better ecosystem. And never upgrade again. So you've written this in a way where you never have to go through and update your components. You can write it in Angular and use it anywhere else. And that's everything. Thank you. We have some time for questions, so if people want to shout very loud, I can repeat them back and respond to anything you have. You can also find me after. Oh, yeah.
Have you run a benchmark on how this affects performance?
Yeah, so if you saw Alex's talk a little bit earlier, he talked about Ivy, so the new Angular renderer. The first benchmark we ran on this was actually build size. And one Angular component is like 200K because I have all of Angular. So we are looking forward to Ivy where we can drop it down a lot. And once it's a lot smaller, you'll be able to load faster and perform better on those benchmarks. So it's kind of like this joint thing where if you're loading 200K of elements like 10 times, it looks pretty bad. So the recommendation right now for us is put all of your elements in one module, load Angular once, get around like 200K, and then when you go through and have Ivy, you can split them out into smaller chunks. So.
Because for now it's like
Yeah. So right now with ngUpgrade, you have both of them running anyways. So it's not like you're going to have a large improvement in size between the two. You already have Angular on there. The difference is like you're running change detection only when you need to. So instead of saying that change detection in Angular triggers like the whole tree in AngularJS or vice versa, which might be more familiar with ngUpgrade, unless you use ngUpgrade for performance, it's a lot more change detection. I don't have exact numbers on how big of a difference it is, but in this case, you're only running change detection on that one component. You're not worrying about the entire tree. Yeah. Anyone else? Yes, Alex.
Which was the hardest framework you guys worked with?
That's a great question. So we've tried it with a lot of them. The hardest so far has been Angular Dart. So it's a lot harder to get access and like kind of work with the custom elements. In general, they already bind up properties, which was an advantage over AngularJS. But yeah, it was also hard because I don't know it. So there's a difference where I know TypeScript, I know JavaScript. Dart was a new language. So there's some kind of balance in there. We found that like every single framework has its own like idiosyncrasies. So Angular has zone everywhere. AngularJS just doesn't listen to properties. And every single framework we've gone down has had something unexpected. So it's hard for us to say build one adapter for everything. You really need like n in, n out. So like 2 n plus n adapters. But yeah, that'd be the hardest. We haven't tried anything else in yet, besides prototypes with AngularJS. So nothing else? Okay. Oh, yeah.
Have you looked into Stencil.js?
So the question, I'm repeating all these questions. The question was when you have you looked into Stencil, and I have not actually, so I don't have any information on that.
Oh, yeah, I can show you.
Yeah, definitely come up here afterwards and show me. I'm always interested in new ways. Okay, thank you.